Every meter of paper is inspected before it can leave the production line. One of nature's fastest-growing trees supports an industry serving billions of people worldwide. A single modern harvester can process more timber in 1 hour than entire logging crews once handled in a day. Thousands of trees arrive at the mill every day, but only a small portion of each tree ultimately becomes high-grade paper. Each truck carries enough raw material to produce tens of thousands of sheets of paper. This facility operates like a living machine, transforming forests into products used across the world. The factory must maintain a constant flow of timber because production never truly stops. Every minute of delay can affect production lines stretching across hundreds of meters inside the plant. Artificial intelligence now evaluates timber quality faster and more accurately than human inspectors ever could. Removing bark is critical because even small contaminants can affect the quality of the final paper. What once required hours of labor now happens automatically in seconds. The next machine will completely destroy the shape of the tree forever. A tree standing for years can be transformed into chips in less than a minute. These small chips contain the cellulose fibers that will eventually become paper. The real transformation is about to begin as solid wood enters a world of chemistry and pressure. These enormous vessels perform the chemical process that separates paper fibers from the rest of the tree. Inside these vessels, temperatures and pressures reach levels capable of breaking down the natural structure of wood. The goal is to remove lignin, the natural glue that holds wood fibers together. Even the slightest fluctuation in temperature or chemistry can critically affect the quality of millions of future paper sheets. The tree is now disappearing at a molecular level, and soon only pure cellulose fibers will remain. Lignin acts like natural glue inside wood, and removing it is the secret to creating paper-grade cellulose fibers. The tree's original structure has almost completely vanished, and only a fiber-rich suspension remains. Cellulose is one of the most valuable natural materials on Earth and forms the foundation of modern paper production. Nearly 99% of process chemicals are recovered and reused in a closed-loop system. Much of the plant's energy actually comes from materials removed from the wood itself. This stage increases brightness while reducing the need for harsher chemical treatments. Thousands of measurements are taken every minute to ensure consistent paper quality. Modern paper mills operate more like chemical laboratories than traditional factories. At this point, the pulp looks nothing like a tree, yet still contains the fibers needed to make paper. One of nature's strongest materials has now become a liquid suspension, ready for engineering into paper. Particles too small for the human eye can still affect the final sheet quality. Every fiber must be prepared before the paper-making process can begin. The next machine is so large it can stretch hundreds of meters across the factory floor. This single machine can produce enough paper every day to fill countless warehouses. The transformation from liquid pulp to paper begins in just a fraction of a second. The paper machine moves so fast, the human eye struggles to follow it. Consistency here determines the quality of every sheet produced later. More than 90% of the mixture is still water at this stage. Despite looking complete, this sheet is still extremely weak and saturated with moisture. The next stage uses enormous pressure to remove water and strengthen the sheet for high-speed production. These rollers squeeze out enormous amounts of water while strengthening the paper structure at incredible speeds. Removing water efficiently is one of the most important factors in modern paper production. The paper now contains far less water than before, but the drying process has only just begun. This area contains enough thermal energy to transform a wet fiber sheet into a finished industrial product within minutes. Temperatures are carefully controlled because even slight variations can affect the final paper quality. The paper can travel at speeds approaching 100 kilometers per hour inside modern production lines. The machine measures thickness and moisture levels thousands of times every second. Modern paper production depends as much on data and automation as it does on machinery. The eucalyptus tree has now been completely transformed into high-grade paper engineered for global use. A single master roll can contain tens of kilometers of perfectly engineered paper. Even microscopic imperfections can force operators to reject entire sections of production. Even microscopic imperfections can force operators to reject entire sections of production. Although they may appear lightweight to the average consumer, some of these finished master rolls can weigh several tons. Every meter of paper is inspected before it can leave the production line.
Modern paper must meet strict engineering standards before reaching customers.
The cutting accuracy is measured in fractions of a millimeter, despite the machine's enormous size. The tree is now almost unrecognizable as it becomes products destined for countless industries. Automation allows facilities like this to operate continuously with remarkable efficiency. This facility can produce enough paper in a single day to fill entire distribution centers. Modern logistics systems are as important as the manufacturing process itself. Products from this factory will soon travel across continents and oceans. Every shipment represents the transformation of thousands of trees into useful products. Despite the rise of digital technology, the demand for paper remains enormous, as evidenced by this endless stream of products. Almost every part of the tree is utilized somewhere within the facility. Waste from the timber yard helps power the factory itself, reducing dependence on external energy sources. Modern mills are designed to balance industrial output with strict environmental standards. Today's paper mills depend on data-driven optimization to remain competitive and sustainable. Behind every sheet of paper lies a massive network of engineering, chemistry, and logistics, working in perfect synchronization. A single shipment can contain enough paper to supply entire cities for weeks. Modern logistics systems connect forests, factories, and consumers through one continuous industrial chain. The same cellulose fibers can become books, packaging materials, office paper, and countless everyday products. The paper continues its transformation long after leaving the mill, undergoing complex processes at incredible speeds.
Sustainable paper is replacing more non-renewable materials in modern packaging industries.
Millions of people interact with products made from these fibers every single day without realizing their origin. Each sheet represents an extraordinary journey, from living tree to engineered material. One of nature's fastest-growing trees, supports an industry serving billions of people worldwide.
Modern paper manufacturing relies on automation from the forest all the way to final delivery.
Thousands of interconnected systems must work together to keep production running every second of the day. Artificial intelligence now helps prevent costly shutdowns before problems are even visible.
Even the most advanced systems require precision maintenance to maintain product quality and efficiency. The total length of paper produced in a single day can exceed the distance between major cities. The secret of paper lies in billions of tiny fibers, forming a surprisingly strong structure. Sustainable paper production depends on replacing resources as quickly as they are consumed.
Many eucalyptus species can regrow far faster than traditional timber resources, supporting continuous production cycles.
Few manufacturing processes transform raw material as completely as modern paper production.
Appears to be a simple sheet of paper is actually the result of one of the most sophisticated industrial systems on Earth.
Within days, these products will reach businesses, schools, publishers, and manufacturers around the world.
A single production facility can supply thousands of different customers simultaneously while maintaining strict quality standards.
The same cellulose fibers can become products used by billions of people every day.
Modern paper manufacturing depends on a supply chain connecting forests, factories, ports, and consumers into one seamless system.
One of the most remarkable aspects of paper manufacturing is how completely the original tree disappears during processing.
Modern paper mills combine chemistry, physics, automation, and environmental engineering into a single continuous process. Every stage depends on extraordinary precision, because a small mistake can affect millions of future sheets. The future of paper production depends on balancing industrial demand with responsible resource management. Behind every simple sheet of paper lies a vast network of engineering, logistics, and environmental innovation. What started as a living tree has become a global product through one of the most sophisticated industrial transformations on Earth.